Okay, so I decided to show your answers as well as just the problem. So you can see your answers right here. So I want you to just keep in mind, how did you get that? And the first thing that jumps in my head is, well, if this were the right answer, anything to the 0 is just always 1, which would mean what you're telling me this answer should be is 4y. So let's keep that in mind as we do the problem. Okay, first things first. It's asking you for the partial derivative of f with respect to x. So remember, y is a constant, x is our variable. So if I were to give you a problem, maybe similar but easier, just something like this, and ask you to take the derivative, we'd have a couple techniques, but usually the one that most students would lean towards as being the easiest is bring this up to the exponent and change up to the numerator and change your exponent to a negative. So I'll use that same technique here, because then that would give us y equals 4 times x to the negative second. Now the derivative becomes quite simple. Using the power rule, the power comes out to the front, so giving us negative 8, x subtract 1 giving us negative third. Then you just have to move it back down to the denominator, giving us 8x to the third. So that would be how we'd go about this problem if it had a similar but easier idea. So now, if I was asking you to do this one, we're going to do the exact same concept. Okay, I'm just going to scoot this over a tiny bit. So I'm going to bring up my denominator, so it's going to give me f of xy equals 4 times xy plus 1 to the negative second. Now, instead of, we still have the power rule, we still have the negative 2 here, so we'll go ahead and bring that over out to the front. So it's going to give us, and the derivative with respect to x, so we'll change it into the new notation, the partial derivative notation. So it's the partial of f with respect to x is equal to negative 8 times xy plus 1 raised to the negative third, just like over there. You'll see, just like we did, whoops, that was not what I meant to do. I meant to grab my highlighter. Just like, same process from there to there, right? But now we have the chain rule to deal with as well. So because we did the derivative of the outside, so now we'll do the derivative of the inside. And the chain rule just says if we have xy plus 1 and we're doing the derivative with respect to x, again, the exponent on the x is just 1, so the power rule says it comes out to the front, which gives us 1 times y times x to the 0, but anything to the 0 is always 1, so we don't need to write that. Plus, the derivative of 1 makes 0, so again, we don't need to write that. Whoops. So that whole thing just becomes 1y, which again, we don't need the 1, so just y. So now, to write our answer, we should end up with negative 8y divided by xy plus 1 raised to the third. Now, I'm going to leave the next problem for you to do because it's amazingly similar. So this problem is just saying do the exact same process, but instead of doing it with x as your variable, we're going to do it with y as our variable. And then just to make sure we have the notation down, the problem after that says take your derivative that you've already done with respect to x, and then substitute in 1 comma negative 1, and the order in which they established up above would be, this would be your x and this would be your y. So we'll go ahead and sub those in. So what we're looking at here, since we have that derivative done, it's right here, we are now just going to say take the derivative from what we just did and sub in 1 comma negative 1. So when I put that in, that's negative 8 times negative 1 divided by 1 times negative 1 plus 1 cubed. And that should take us through the problem. So that gives us 8 divided by 1 times negative 1 is negative 1. Sorry, negative 1 plus 1, that's 0. 0 cubed. Uh-oh. Can't divide by 0, so this would be undefined. I hope that helps. Let me know.